Okay, excellent. Hello, welcome to I Love Chemistry with Dr. Winchester. We're going to be looking at valence shell electron pair repulsion theory today, which we call VSEPR. Okay, it's valence shell, because they're the valence shell of electrons. Those are the ones that are involved in bonding, the outer shell, if you will. Electrons, so we know electrons don't like electrons, so they try and repel each other. Electron pairs, because we know that electrons hang around in pairs even though they don't like each other. We're a little bit offended by that, but we don't go into it. And then repulsion, because the electron pairs repel each other, so remember that the pairs of electrons want to get as far away from each other as possible. Okay, so this is a very stepwise kind of method to do, but it allows us to tell the shape of any molecule that they're going to ask you about in the A-level syllabus. Okay, so for example, B part 1 on your question sheet asks for predict the shape of boron trihydride. Yeah, something like that. Or trihydroborode. Oh, I don't even know. Borotrihydride. Trihydroborate. Boron trihydride. Should be boron trihydride. BH3. We'll cut that down.
Yeah, I think.
Yeah. So our first step is to count the electrons from the central atom. So I guess our first step is to decide which of the atoms is central. Well, it must be boron because there's only one of them. So you're not going to have one hydrogen surrounded by a boron and two hydrogens. That'd be a bit weird. It's always the one that's on its own is the central one, and then surrounded by the electrons. So we look at the electrons in the boron. So how many electrons does boron have? We look at the periodic table. It's in group 3, so 3 electrons. Now we need to look at how many extra electrons the boron's getting from the boron to hydrogen bonds. Okay, so boron to hydrogen, there's 3 of them, and every single bond has 1 extra electron, because one of the electrons was already borons anyway, and we've talked about that. So an extra 3 times 1, an extra 3 electrons. Then we have to look at the charge. Is there any charge on it? Well, you don't have to do much thinking about that. You just look at it. BH3, does it say plus or minus? No, it doesn't, so there's no extra charge. So 0 minus there. 3 plus 3 plus 0 is 6. The next step is always 6, therefore 3 pairs. 3 electron pairs. Now we know, and you should know, 3 electron pairs, the best way for them to get away from each other is to make a trigonal planar molecule. Okay, so trigonal planar is based on this trigonal planar. So you have boron in the middle, and then 3 electron pairs. Okay. Now the next step is to think how many of these are bonding pairs and how many are lone pairs. So if you look there, there's 3 hydrogens. So there must be all 3 of these must be bonds. There's no. If there was 4, then 1 would be a lone pair, but there are only 3, and we've got to fit 3 hydrogens on, so they must all be bonding pairs. Okay, so that BH3 is nice and simple, a trigonal planar. What's the bond angle, they may ask you? The bond angle in trigonal planar, they all repel each other exactly the same, so it's 120 degrees, 360 divided by 3, 120 degrees. That's it. Good, good, good. Right guys, the next one we'll do is PCl3. So again, how many electrons? First step, how many electrons from the phosphorus? Phosphorus is in group 5, 5 electrons. How many extra electrons does it get from the P to Cl bonds? Well, there's 3 of them, so it gets 1 extra electron for every P to Cl bond, so another 3 electrons. Is there any charge? No, no charge, so 0 electrons there. Add them up, 3 plus 5 is 8. Therefore, 4 pairs of electrons. If we have 4 pairs of electrons, we know it must be based on the tetrahedron. Must be based on the tetrahedron. So tetrahedron we know is the phosphorus in the middle, and then 4 things. We draw 2 in the plane of the whiteboard. We have 1 wedge coming towards us, 1 dash going away from us into the plane and out of the plane. And those are going to be our electron pairs. Now we need to think how many of these are going to be bonding pairs. So we look 3 chlorines, so we've got to fit 3 chlorines on. So let me just put my 3 chlorines on. They each take 1 electron pair each. So the other pair must not be a bond. So I'm going to scrub out the line and put a lone pair of electrons there. Okay. So this I sometimes put them into a little orbital. This is my lone pair of electrons, and then I have 3 bonding pairs. Now the shape's based on the tetrahedron. If I'm going to name the shape of it, I don't think about the bond, because the lone pair, because I can't see the lone pair. The lone pair is just a lone pair of electrons. It's not like a bond where I can see the atom on the other end, therefore think of its shape. So I ignore that and think of what does the shape look like now this. So if I think of it, if I draw it like a little 3D shape, just linking up the atoms, it's kind of like a pyramid, and it's a trigonal based. It's got a triangle at the bottom, so we call it a trigonal based pyramid. Now the last little thing now is you've got to think of the bond angle. So remember, we only look at the bond angle. It's only the angle between bonds. It's not the angle between a lone pair and a bond. Now a lone pair repels more strongly than a bonding pair because the electrons are closer to the phosphorus centre because they're only owned by the phosphorus doesn't have to share it with the chlorine. So because the electrons are closer, it repels the other things away more. So it therefore narrows this bond angle because they're getting repelled more from the lone pair and getting pushed together. So it would have been 109.5 to start with because that's the tetrahedron bond angle. Now it's going to be narrowed and we say 2.5 degrees for every one lone pair. So there's one lone pair, so 109.5 minus 2, so 0.5, my apologies, minus 2.5 equals 107 degrees. So our bond angle there is 107 degrees. Okay. So the next one we'll do will be SCl2. Okay, so I'm not going to try and name it just in case. SCl2 will be sulfur in group 6 and then 2 chlorines from group 7. Okay. So first of all we need to spot which is the central atom. So it's the one there's only one of, and it's sulfur. So how many electrons from the central atom? Group 6, therefore 6 electrons. How many electrons from the sulfur to chlorine bonds? There's 2 of them, so 2 extra electrons. So is there a charge? No charge at all, so no extra electrons there. If it was negatively charged, that would be 1 extra electron, because the whole thing has got 1 extra electron, that's why it's negatively charged. If it was positively charged, I would take away electron, because it means that one of those electrons has gone somewhere else. So we have to take away electrons. So if you have a problem with that, just either add or take away the electron, then do exactly the same principle. Okay. Add them up, 6 plus 2, again is 8. Therefore, again, is 4 pairs of electrons. So therefore, we're based on the tetrahedron. So sulfur in the centre, again, I'm going to do my 4, a wedge coming into me, a hash coming out of me. But now, I only have 2 chlorines to fit on. So let's just put them, I'll put them in the plane. I'll put them there. And now these 2, they're not going to be bonds, so I wouldn't really draw them as lines now. I just put 2 little lone pairs of electrons. So a little double dot there, maybe give it an orbital. But you just put a little double dot really, and a little double dot there. Okay. So now it comes to naming that shape. We only think about the bonds and the atoms. We don't think about lone pairs when we're naming the shape because you can't see the lone pairs. Not that you can see anything because it's T. But anyway, here, the shape of this is just bent. It's just like, it would be linear if it was all straight up and down, but it's bent. So we just call it bent. And the bond angle here, where it's based on a tetrahedron. So the original bond angle, if there was no lone pairs and everything was repelling each other equal, would be 109.5. That's the only number you need to remember. But we know for every lone pair of electrons, it shoves these 2 closer to each other because they repel more. Shove those 2 closer to each other by 2.5 degrees. So there's 2 of them, so that's going to be 5 degrees. 2 times 2.5 is 5. Okay? So we take away 5 degrees because it's making the angle little to give 104.5. So our angle there is 104.5, and that's it, job done. Yes.